Okay, shall we get started? This is where we stopped last time. The phases that we were talking about. Like I said, a lot of data scientists focus only on experimentation stage, and these are some of the best practices that we were talking about. That when you conduct experiments, keep modularity in mind, keep reproducibility in mind, right? Create packages, create libraries out of your code, they can be reused, right? And have more than one metric. If you look at this particular paper, it talks about the issues with one metric. One metric doesn't suffice. In fact, the researchers here, these were folks actually at Microsoft. And when I was working in Microsoft, we did run into this problem. We did actually end up using this particular setup. We have more than one model metric, and one metric is not sufficient. Sometimes I gave you an example with rock AUC, right? It is at a very aggregate level. So even if you do a very good job, and in case of imbalanced data set, if you do a very good job of predicting negatives at the tail, at the bottom of the list, right? Your rock AUCs will still shoot up actually. It will be a good rock AUC. But then you'll realize that at the top, the metrics are not moving. Okay? In such cases, you'll rely on the ranking metrics. The ranking metrics, sometimes they also could mislead you, right? So they also rely on simulations. So you need to come up with this setup where you could have, if possible, have replay of the logs, have simulations, have more than one metric. Yeah. Test data should always be, when you work in industry, right? The data on which you are testing, it should be reflective of and representative of what you are going to see in production. Typically, you divide your data into when you split, right? And like I said, when there's an imbalance, you try to correct for it. You can correct for your data imbalance in your test data also, which is okay. But then there has to be a very golden data set, a pristine data set, which is reflective of production setup, right? The traffic that you will see over there. And that is something that you have to evaluate on. Then you'll realize that even it impacts your metrics also. PRAUC, for example, or there's a metric, we talked about log loss, right? There's another metric called relative information gain. You are aware of information gain in the context of decision trees. Relative is relative to the base rate. If you use only the base click-through rate as your prediction, right? What is the information gain? And you normalize with that. The point is that even that metric is called RIG, even RIG or PRAUCs, right? These metrics will be impacted by the distribution of the classes in your data set. Okay? Rock AUC, on the other hand, will not be, because of the definition, because of the FPR and the TPR. They are class specific. Okay. The next two phases are primarily about system design and deployment. These are some of the engineering things that you need to be aware of. I know that you will not find them very, very attractive and glamorous, but like friction, it's a necessary evil, right? You have to deal with it, unless you saw the tweet in the morning, right, that I shared. Otherwise, your models will be basically cooling the chairs. So this is where few things come into play. You talk about how your solution will be used end to end, right? Not in isolation. There is a good possibility that you built your solution keeping one thing in mind, but when it is integrated, I was just talking to him about vernacular query translations or spell correction. Or let's say we talked about the vocabulary gap, right? The query that needed reformulation. Let's say that you're working on that particular problem. Okay, and this is why it is critical. So you need to understand the system. You got you got your original query in place, the query that users fired on the system. Okay, and you got that as an input. You saw that the results were not very great, okay? And you figure it's a case of a query reformulation. I mean, I need to reformulate this query. I need to drop some terms. I need to add some terms. I need to replace them, or I could altogether come up with a different query. It's a query reformulation. So you started training your model. Okay? Original query, you got the replacement, and you said, okay, guess what? I've got a very great model here. I use translation model. I use transformers. As I speak transformers, how many of you are aware of transformers? Transformers are deep models. How many of you are aware of RNN models? Okay. Neural networks, pretty low. Great. RNN is a flavor of neural networks. It's a sequential network. Okay. So all the terms in the sequence, all the entities in the sequence. I mean, I'm using term entity here because it could be used for time series prediction also. But let's say you are given a text. Right? Can I predict the last word in that sequence? I could use neural network. I could build a dependency. Okay. And the good thing is that there is RNN has certain characteristics. There is weight sharing and all those things. Don't worry about it. But because of the sequencing, I have to process each token in sequence. Okay. So it has a certain implication. In productions, if you are working with sequencing, it takes a hit on inferencing time, the prediction time, because you have to go step by step. Transformers, on the other hand, are deep neural networks where they break, they break this hard sequential dependency on each other, but they tackle it in a different way. Okay. They simply say that each token is surrounded by other tokens and that provide a context. There is a notion of attention also over there. I talked about collaborative filtering. Attention is related to that. It simply says that a token in a query, right? How similar is it to the other tokens in the query, which simply means that can other tokens in a text, in a sentence, provide me some information about this a token of concern. Okay. So that is called attention. How attentive they are on a particular token. So why I'm telling you that, right? I was talking about reformulations. So RNNs, if you use your solutions like RNNs, right? The prediction times could be higher. So and even training times could be higher, right? Transformers can alleviate some of the problems, but they bring their own problems. Transformers are much deeper. Okay. Then again, they will have a lot of latency. Okay. So we're working on a problem of translation. Okay. And it had 6 layers. So 6 blocks. Each block itself has a couple of components in the transformer, but you don't need to worry about it. The standard vanilla transformer, it comes with 6 layers, and it's a sequence to sequence model. You're given one sequence and you predict another sequence. Okay. So the output part is called decoder. The first sequence, the input sequence is called encoder. Okay. So encoder decoder setup. Now, when we were working on that vernacular translation problem, in that particular case, the query was coming in multiple Indian languages. One of the languages was Hindi, and then we also have Tamil, Telugu, Kannada, South Indian languages, Marathi, Gujarati, Bengali, right? And we had to translate it into English and then fire it on our index, search index, to match it. The catalog that has been uploaded by the sellers, it is in English. Most of them are uploading in that. So it is our responsibility to match the content so that I can serve those queries. So the model that we built, right, we used vanilla transformer with some tweaks. That was very latent. When we say latent, the prediction time was going into hundreds of milliseconds. And as I explained in the beginning, it was just part of one of the steps in the overall query processing process. That was very high. So we had to do a couple of tweaks on that. And these are very, very critical steps. Otherwise, that model would have just sat out there. We could not have productionized it. What we did was a couple of things. We experimented, experimented with certain things. We reduced the number of layers. I mean, that's the first thing that you could do. When we dug deeper into that, we found that every time encoder was invoked. So decoder, I'll be predicting each, when I'm translating the input query into output. In the decoder, there will be token by token generation. Okay? One token will be generated. So for every token generation, this encoder was invoked. Okay? And that's an unnecessary step. All the information that I wanted out of encoder was available to me after the first iteration, after I generated the first token. So I could take it out of the loop. So if I use the standard libraries, right, they're not optimized for that. So when we wrote our custom implementation of this solution, instead of using the library, we took that loop out. That brought down some, that shaved off some milliseconds. But then there was a trade-off. As we came down from 6 layers to 1 layer, right? There were some trade-offs. What could you do? We'll talk about it. There is something called knowledge distillation. You could distill whatever you have learned in 6 layers into 1 layer by another step. But my whole point here is that you have to be aware of the restrictions that you will have in a system, in a production setup when you are deploying your solutions. There will be latency, there will be memory constraints that your model has to use only so much available memory, right? Memory is not unlimited. Right? Sometimes, and these things are called, by the way, NFRs, non-functional requirement. The functional requirement was just translation. You translated a query from one language to another. Non-functional aspect of it was that it has to use so much memory, it can't exceed a particular memory, it has to return the prediction in so much time, right? So you have to be aware of the NFRs. The other thing that you have to be aware of is sometimes you will find that the data, someone was talking about distributional things, right? That's one thing. The other thing is that when you develop your solution, sometimes you will, and we'll cover it later, Python is a great ecosystem for developing models. It provides libraries and everything. But when you go to production systems, real systems, right, they, more often than not, you will find that they are developed not in Python. Although we do make use of it, and I'll cover that. But sometimes the serving system, the core engineering systems, the ecosystem of choice is Java, right? Now, what does that mean? You built a model on one language, one setup. You are now porting it in another language. Okay. When you're doing that, there could be a loss in this porting. There could be a loss in translation. There could be accuracy loss. Sometimes there could be other losses also. I give an example of CTR prediction. Once I built my model for CTR prediction in ads in Flipkart. Right? So we had features and everything when we were deploying it in production. So what we did was logistic regression. I mean, we use logistic regression over there. Okay. The features will be indices in an array. So you have a feature vector, right? So if I'm using, let's say, the historical count, the impressions of an ad, the clicks of an ad, all right? These were the two features that I was using. So I gave them two indices in my feature vector. So far so good, so nothing is problematic here, right? But this was developed in Python. I created enums for them so that these are readable. I mean, people won't understand that ad impressions is feature ID 10 and this thing is feature ID 11, right? People won't understand that. I mean, coders won't understand. So we generated enums, and enum was assigned a value of 10 and 11. There was a developer actually who ported this solution from Python to Java. That guy swapped these two enums. Okay, that was my first model in production. That was my first model in Flipkart in production. Okay. I was seeing some offline gains, and in production I was seeing the ROCs of 0.5. When you say ROC, the area under the curve of ROC curve, it also tells you, it also has a physical significance. Okay, the interpretation is this, that if you randomly choose a positive sample and if you randomly choose a negative sample, then what is the probability that your model will place positive over the negative if you were to rank them? Okay, that's one of the interpretations. If it is 0.5, it is 50-50. It's a coin toss. It was coming as 50 and I was surprised. I mean, my offline results were not holding. Right? So these things do play out. So you have to be careful about it. And that led to me to basically putting in efforts into another component that was called feature parity. For the same training record, right, which I was predicting, right, then I was predicting, I was logging it also. Like we said that the data has to be instrumented. So we logged it. We logged the feature vector. We logged the model score. We logged the user feedback, click or no click, right? Everything was there. Next day when I'm using that data for training, I could use my model first of all to predict for that feature vector. I could get an output, right? And I also logged in production what was the output I gave at that point in time. And I found that my model offline is giving a different score. And when I was serving it, when I was inferencing in production time, the scores were different. So this is called parity. You need to figure out that there is a model parity, score parity. And this can, next level of detail would go into feature parity. Now I started digging into the feature parity, right? Because this was, I could basically take an example and I could take a training instance and I could see there was a difference in the feature. But if you have to do it in aggregate level, I told you about billions of records in a day, right? At such a level. And what you do is you aggregate the scores, you compute the score distribution of the model over the day and as predicted by your, as your offline model, and figure out what's the delta error between them. If it is beyond a tolerable limit, then you know something is amiss. And you do something similar for your features also, at least for the most important features. Yeah. So these things are very critical. Like I said, the other thing is that the features themselves could drift. Okay. Sampling we talked about, sampling could change your model metric, right? When we talked about imbalanced data set, you had 2 positives, 98 negatives. I wanted to create a balance. I created 2 positives and 2 negatives now. My probability rates will now, if I develop a model on this one, right? I mean, the prior probability will be 50%, right? But the prior probability of being true, right, of being positive was 2% versus 50% because of the sampling change. Now it has a score distribution change also. Can it have an implication? It can have an implication if another component is using it. What could be that component? Let's say I was showing ads. Remember we were talking about clickability because advertisers are paying by clicks. So I can simply rank them by PCTR, the probability of the probabilistic CTR, or probability of click. Right? So if I were to use 50% or 2%, as long as it was monotonic, that's not a problem. But if I wanted to rank them by expected money that I will get, the expected money would be the amount, the bid that the advertiser is willing to pay, the price that advertiser is willing to pay, and the probability of click, right? So it will be PCTR times the bid or the price of that ad. Now you see this PCTR now, if the scale changes, right, and there's another component coming in, which is the price component, your ranks could invert because of the score distribution of the model scores. And these things can go on. I mean, when you move your models from logistic regression in the background, let's say you said that now I want to go into nonlinear models, I want to try out random forest, GBDTs, neural networks, then you will also find, because this will be more accurate, your score distributions will also be different. So you have to be aware of that. Feature drift is that the feature that you had yesterday versus feature you have today, or that feature that you worked with in your training, right? The distribution of that feature. Is it same as you are going to see in the real time? Okay. So I just wanted to talk about one thing. This was an example actually of the drift. Right? The first is an example from Yahoo. Okay. Yahoo, when it was personalizing it, it was using user cookies as one of the features. Okay. But also for randomization, they did something so that I forgot the reason. They would change their cookies. They will recompute the cookies. It's a hash code. Okay? They will change the hash code after every 15 days. And there was a guy actually who was doing the modeling. Right? He found that the model performance had a certain shift. Right? It followed a peak kind of thing. It went up and went downhill. And after this cycle repeated after every 14, 15 days. Because every 15 days, the cookies were churned. And someone was using cookie ID as a feature. Now, why a shift? Because you will slowly build the history for that cookie. Right? And by the time you have learned something like that, right, the cookie would have churned. Something similar happened in Microsoft. Listing ID is the people, when they're placing their ads, they assign an ID to it. Sometimes people stop showing their ads. Okay. And when they come back with those ads again, they will create a new ad. Though the ad content and everything is same, they give a different listing ID. If I were to use this ID as a feature, right, if I were to memorize for it, The moment this ID is churned, I've lost history about this guy. Okay. Now this thing reflects in your training data. Your features are changing. There is a distributional change in the feature, and you have to be aware of that, is what we are talking about. So you should, there are multiple ways to go about it. You could do QQ plots, and we'll talk about it. The other things that you need to worry about when you are deploying solutions or integrating, that can it scale, right? And at a particular concurrency. Right? When I say concurrency, it means simultaneously on your system. So the transformer, the vernacular translation example that I gave, we brought it down to 20 milliseconds by a few tweaks, from 80 milliseconds to 20 milliseconds. It was all right, right? But that was for one request. Now the next question is that if I have a QPS of, let's say, 20,000, QPS of 20,000 means that 20,000 queries are hitting my system per second, and I have to translate them for the vernacular system, right? Now, can it respond back in 20 milliseconds? The answer would be no. Simultaneously, it will be no. There will be a lot of load on system, right? So, can it scale? Then what would it take actually to scale your model? Maybe you can, there is a term called linearly scaling, horizontally scaling. How many of you are aware of vertical scaling or linear horizontal scaling? Not many. Okay. Horizontal scaling would mean you add more machines. Okay. So if you visualize as a machine sitting here, you horizontally keep on adding in this line, you keep on adding more machines. And as the requests come, there will be a lot of different machines, right? Vertical is that in this machine itself, you add more memory, you add more CPUs, more power to it. So you have to be aware of that how scalable is your model. The other thing is measurability. We have emphasized a lot on the measurability. I also gave you an example of ROC AUC, that especially in the case of imbalanced data set, where negatives are huge, right? So remember the false positive rate, the denominator in the false positive rate was total negatives. Now if my, sorry. Let me take it. Okay, the question was in the case of, I think, parity. I assume that that's the context in which the question is asked. And the answer is yes and no, right? The example that I gave where you developed your solution in Python, but you're deploying in Java, right, in JVM system, it may not. It will not actually, rather, because that was Docker or container for your model development. All the libraries and everything, it was for Python ecosystem. That won't help. But it would help if you're able to deploy your Python solution behind a Python web service, Flask or something of that sort. In that case, it would help. Docker would help because you have the setup on which you did your model development and you deployed it as it is. So for that, the answer is yes. Yeah, so we were talking about the ROC AUC. So I gave the example of false positive rates. The denominator was negatives, and negatives are running into millions, right? And let's say I have my positives in few thousands, right? The TPR, in case of TPRs, my positives would be, true positives would be in the numerator, right? But point is, if the FPRs, even if I bring in thousands, right? And if my millions, my negatives were in millions. So in that case, my false positives, even if they moved in by thousands, right? It won't make too much of a dent in my false positive rate. You see, the false positive rate was false positives, right? Which were actually negatives, right? But I thought that no, these are relevant, and I made them positives, right? How to see the questions here? Yeah. And we'll talk about monitoring the deployments. Yes. We'll talk about that. Okay. Yeah. For in this particular case, so I was giving that example, right? The false positives. My even if my false positives moved in a few thousands and denominator was in millions, right, which was the total negatives, right? My change in FPR won't be very significant, but there's a good possibility my true positive rates, because the moment in true positive could be significant even if I move by hundreds, right? Because the denominator there itself was in few thousands, right? So the hundreds in thousands would be fine, right? So TPR would move up, my false positive would remain as it is. Now you'll see that my area under the curve has increased, right? So it is giving a false sense, because now when you are showing these results to the user, it's possible that your false positives, which are actually negatives, right, they are swamping your true positives. So you have to be aware of the model metrics. You have to look at multiple metrics. Partial ROC AUC is that you start looking in the beginning part of the curve, initial part of the curve. There's a good possibility that at the later part of the curve, you will make improvements, but they are not significant. I mean, they are not practically useful to you for your model. I mean, if you started making the improvements at the false positive rates of 50%, right? And if my imbalance was such huge imbalance, 50% false positive rates is not acceptable at all. And we talked in the beginning, the relationship between your model metrics and business metrics. Remember, my eventual goal is to see how my business is shaping up. I can improve my clickability, but is it resulting into the revenue that I was expecting from those clicks? Maybe I was not ranking in them the right way. Maybe I should have ranked them by the expected money, even though I modeled for my CTR. Right? So you have to be aware of those things when you're deploying. The moment you rank your content by expected money, now you realize that you've changed the ranking. So your models, ROC AUC or the PR AUCs or any metric that you saw offline, that will be different from what you will see now in production, because you've inverted the ranking because of that multiplicative component. You have to be aware of them. The other things to be aware of is that we also talked about it in the past, that is CTR my primary objective? But is it resulting into, let's say, people buying some products and then returning them? So click-through rates are fine, but are low quality products coming in? These are secondary metrics, and they should have been basically agreed upon when you were first doing the problem formulation and agreeing on the problem. But if your return rates, in case of e-commerce, if return rates are increasing too much, then maybe you need to go back and look into the problem. Maybe you need to go back into the you still model for CTR, but remember we talked about CTR with constraint CTR with quick back rate. So P CTR times plus 1 minus lambda times or lambda times 1 minus QBR, quick back rate. Or clicks themselves could be, the labels themselves could be cleaned. When you are generating your data, you say that I will only take those clicks when people clicked on the product link and landed on the product page, when they spent at least more than 10 milliseconds, or no, sorry, more than 10 seconds or 20 seconds. Then I would say that, okay, these are relatively cleaner clicks. Right? So we could do that. So these are critical things, is all I'm saying. And data pipelines, your data has to be automated. Remember, again, the case I told you about the academic collaboration that we were doing with that PhD student, right? He had this pipeline set up. His code was modularized. So that helps a lot. I mean, can you generate your data? Now in production systems, you will realize you have trained your model today. Tomorrow, the user's behavior could change. Maybe there was a sale, there were discounts, there were more offers on e-commerce ecosystem. So users' feedback could change. So you have to retrain your model as quickly as possible. Maybe that's a requirement, systemic requirement, to keep pace with the changing user behaviors, keep pace with the changing content. Some offers will expire tomorrow. The product which has an offer today may not have an offer tomorrow, which means the clickability of that product tomorrow might be different than today, right? So you have to keep peace with it. And for that, you need to retrain your models. If you have to retrain your models, then your data generation has to be automated. You can't take a pause here and say that, no, I'll generate the data and it takes 1 day. So if you can regenerate your process, it's all about efficiency more than anything else. And automating things also bring in reduction of errors, lesser the manual interventions. I just talked about it. There's a degradation of the model, right? There's a potential degradation of the model, and I have an example actually, which I will show. I have a production model, and I'm measuring the ROC AUC of that model and how it varies or how it degrades over a period of time, okay, if I don't retrain that model. And that has a huge bearing. Once I figure out how it degrades over time, what could be the training frequency? These things come into play, right? Do you need constant labeling, for example, when you're training? The search query patterns, as Flipkart expands into lower tiers of India, tier 2, tier 3 cities, the kind of queries that are coming into our system, they are changing, right? So the model that I trained with the query patterns of yesterday, they will be different than the models that I will train today because my query patterns have changed. So now in the supervised setup, when I sent a query and the related products or relevant products to the human labeler to label for me, right, I will get a different labelings, different set of labels. So I need to constantly keep on sending them to the labelers so that it can capture the change in the patterns, the ground truth that I need. Yeah. Now this is model training. So labeling. Okay, I understand your question. The point is the way you train your models. The way you train your models is you always work as a subset. So you don't start with day 0, and let's say you started with 10 days of data. On 11th day, it's not that now you are training on the 11 days of data. That is also a modeling strategy that you will say that I will always train on 10 days of data. So it's a rolling period, rolling window of training data. Does that answer the question? Okay. In the Bayesian setup, Bayesian setup also helps you actually deal with those kind of things. You can learn about the past, but don't forget about them in the future. But it entails in other programs that they also have to decay if you keep them in memory for so long. So people use both things. Most common is you retrain on the last 10 days. But in the Bayesian setup or in the online setup, you just train on the latest data. So online learning will help you actually over there. The question that you're asking, because you are not keeping the data, you are just seeing the data, updating the model and forgetting about it. The other thing is that there is a variance in the model metrics. You will also find, someone was talking about bootstrap sampling, right? And you will also find when you are creating random forests, let's do one thing. The features that I've chosen for one tree, right? They are same for all the trees. The only thing that I'm changing there is bootstrapping of the data, right? What do you think? Will the prediction of each of my trees change or not? It will change. There will be small variance, right? So there is a variance in the model, right? So when you train, typically you train with the sample of the data, and you never know the true population. If you think about statistics, right? I don't have the entire 10 years of data to train on. I can't train on that, right? So like I was saying, I can use last 10 days of data. So that 10 days of data is a sample from the overall population. So when I'm training with different samples from the population, remember in basic statistics, there is confidence interval. How many of you are aware of confidence intervals? P-values and others. Okay. The point is, even if here, right, I divide it into 10 groups in this room and ask you the average age. Let's say you are randomly seated here, right? Average age. The average age will vary from group to group. There's a small variation, right, in the output. So it's the same case here. Now, why I'm telling you that is that there is a small variation in the model matrix, and that is absolutely fine. You have to define your tolerance. If the model dips below, let's say if I was monitoring on rock AUC, if the model changes by more than absolutely 2 percentage points or 1 percentage points, then I have to investigate, because there is a good possibility that a corrupt model can go into production and it can mess up my entire system. So we need to have these checks and balances in place. You monitor the model matrix. How was it in your training, and how is it trending over days? So if I retrained the model on today's data, so it's retraining is not only about just using the latest data and pushing it to production and deploying it. It's also about putting in checks. Did this retraining help? Right. There's a good possibility. Sometimes it can happen if the data was bug in the data. There's a possibility that this model could be corrupt. That cookie churn example that I gave, right? If the cookie churned, right, and my model metric could now all of a sudden could be different, and I could catch it that way. You have to worry about how are you going to deploy your models. Is it going to be used in batch mode? So like I said, in search, when the user is sitting with a query, there are many models which are kicking in, and they're predicting we are featurizing at that, we're creating the feature vector at that point in time. We're invoking our models and making a prediction for inferencing, right? So that is one kind of setup, which is called online prediction. Then there are offline predictions also. So you also need to be careful or be aware actually, where your system or how your system will be used. Right? I gave an example of query reformulation. The constraint was 5 milliseconds. I could develop my model offline and then create a lookup table. I don't have to do inferencing now, model prediction at runtime. Right? So multiple things come in, but you just have to be aware how your model is going to be used. For example, if I have to do demographic prediction, what is demographic prediction? Can I predict the age group of a user from the browse behavior on the site? Can I predict the gender of the user? You know that in India, anyways, one phone will be used by multiple users, right? In a family at least. So at least for a session, can I predict the behavioral gender of the user? That at this point in time, maybe it's my mom actually who's using it, my sister, my wife, or my brother, right? So can I predict that? Now, so you have to figure out even in demographic prediction, are you predicting the demography of the user in general or in session? And that changes the things. I mean, how will you deploy it? So you just have to be aware of that. I mean, will your model be invoked in real time, in online or offline? Few good practices, do canary deployment. How many of you are aware of canary deployments? By the way, I've been speaking a lot about deployments. How many of you understand deployment? What is deployment? Yeah, deployment is actually you develop your system on your laptop or on some development machine, and then putting it on the server, which is seeing the user traffic. So that is deployment. You deploy your models over there, and deployment can happen in offline, online. So when you're deploying, you will find that Google search, Flipkart search, right? We are getting millions of requests, right, in a day, hundreds of millions, and the query per second are huge, right? So we need multiple servers, serving machines, multiple servers to cater to request. So your request could go to machine number 1, and his request could go to machine number 2, and her request could go to machine number 3. Right? So there are multiple machines, and effectively translates that if you have n users and k machines, if I'm uniformly distributing my load, n by k requests will go to one machine, right? Now in deployment, what I could do is when I'm deploying my model, there's a possibility that this model could have certain issues. So I have to be a little circumspect about it, careful about it. So there is a process called canary deployment. Canary deployment is to just deploy in one of the machines. And even on those machines, you could do one thing. You can do a coin toss. This is called traffic ramping up. And coin toss, so 10% of the time, you will serve this model, 90% of the times you will not. So that you slowly see the user behavior, the performance of this model. You become careful, and as you see that, okay, this model is performing well, doesn't have issues. On that machine, you can ramp up to 100%, or you can ramp up to all the machines. So that is called canary deployment. Shadow deployment is another phase that all of us use Linux here, right? There's a T command that you have. Right? A request comes. Today there exists a model 1 in production. You will continue hitting it. You have built an improvement over it, model 2. You do one thing, you send a request to that also, but you don't show the response back to the user. Response will still be shown by model 1. But at least you will see that functionally it is working, integration, everything, feature vectors, the outputs that you're seeing are fine. That's a shadow deployment. So it's all about being careful, because remember, a single change can have an issue. It has a cascaded effect on your users. The user experience could be bad, right? Or it could be the revenue impact. So it's all about that. Online AB is simple. You made one change. I had one model in production. Okay. You had logistic regression model for, let's say, classification for CTR prediction in production. You developed a model of on your development box, which is GBDT model or random forest model or a neural network model. Okay. And you want to measure, you found that, okay, offline my log loss has come down. Okay, my raw KUC has gone up. I looked at a couple of metrics, all the hygiene metrics. There's a good improvement. I want to take it out to production, right? Before you take it out in production, you do trials. Are you aware of drug trials? How many of you are aware of drug trials? Right. So those are called, I mean, in drug trials, of course, it's there is one thing you can't do, typically RCTs, but in some cases you can do RCTs, randomized control tests, right? So very similar to that, you divide your user, just like I said, when I wanted to figure out the average age of the group, I divided users into n groups here. Right? So I divide my traffic by users, that one user will belong to one bucket. So AB is bucket testing. It's also known as bucket testing. Okay. So one set of users will go into bucket A, another set of users will go into bucket B. And then there will be pool of the users, which will be where rest of the model will, rest of the traffic will go, which will still be served by your production model, which is serving. But you create A and B so that the traffic is comparable. Otherwise, I could have split my users into 90 and 10, right? 90% serving on model 1 and 92 on the new model, or 10% on the new model. But the comparison wouldn't be fair. So that 90% is split into 80 and 10, and now 10 and 10 are comparable. That's all. So this is A/B testing. Okay. You see, because it's randomized, the users are split evenly and uniformly. Then you know that if there is an improvement, it will the model 2. Any improvement that you will see, maybe the purchase rates have gone up, the number of clicks have gone up, the revenue has gone up. It should reflect here, and that's a litmus test for your models. That's the actual data. So you do A/B tests of your model. Okay. And once that has, once you have gotten a green signal there, it works. Then you go into this shadow deployment that function. By then you have already done shadow deployment, so it's okay. But then you would go into canary deployments to ramp up the traffic. So Google has this framework. So I've linked these papers. Sometimes doing experiments, when I split this traffic into 10% each, right? There's a challenge over there, the traffic, the number of experiments that you could do. Let's say I figured that I need to split my users into 10% each, 10 buckets of 10%, which means I could do only 9 experiments at a time, one being the control, right? So in search systems, in Flipkart, let's say, there's a home page where I show recommended content to the user. When you land on a Flipkart homepage, when you open the app, you will see some of the contents are based on your past interactions, past interests. You will be shown some recommended products. And then there is a search bar, you search on it. But I know that any change in the recommendation system is not going to impact my search system in general. Can I make those assumptions? We do make such assumptions. Okay. So this is called dividing your application into layers. Search layer is not going to be impacted by recommendation layer, and vice versa. We make those assumptions. Okay. So now at search layer, I can divide my users into those buckets. Separately, I can do it on recommendations. So now all of a sudden, if I could do 10% experiments, I could do now 18 experiments, 9 on each layer. So that is what it means when you're talking about A/B testing. So Google has this framework. It's published this paper. It's a very good paper. Netflix has a different strategy to it. It does bandits. So on the go, you can try out 2 algorithms and see their feedback. There are multiple ways. When I just talked about recently, this is the deployment process, right? When you deploy the models, typically in machine learning, Python ecosystem is very, very rich, right? And same analogy holds for the standard engineering development or web server developments. Any server that you're hitting, more often than not, you will find that it is served by a Java platform. So the support over there is pretty rich. Okay. Now there's a disconnect when you are doing your machine learning development. So I gave an example, right, where the 2 enums were exchanged, and all of a sudden, when I developed a model in Python, and when I am porting it to Java, there are areas of error. As many links as you will have in your system, the possibilities of error will increase. Correct. So the multiple ways. Sometimes what we do is this. The question came, Dockers. Right? Dockers is not exactly connected here, but you developed your models in Python. Can I deploy it in Python? And the answer is yes. I mean, you can do web deployment in Python. The only problem is that the models which will invoke, the scalability of Python, it's arguably poorer compared to Java because of its GIL. GIL is global interpreter lock or interpreter lock, because Python is an interpreted language. So it can't, in one Python process, you can't have more, it doesn't support multi-threading. It will spawn a child process when you say multi-threading, which means the different CPUs will be launched, and processes, have their own overheads. So it doesn't scale. But if I keep that aside for a moment, let's say I can throw infrastructure, I can throw more machines, then you can do your models, you can deploy your models on Python web servers. When the request comes to your Java web server, you make a web service call behind the scenes to this model. But as you would have understood that there's a network cost now, although these are co-located machines, but there's still a network cost. So there are pros and cons. The other is that Python setup can require more machines. So the cost of serving could be more also. So you have to be aware of them. But like I said, the good thing is that those errors, the chances of errors, you developed your model in Python, you're still serving in Python, and you're fine. Right. There is other way. So if that network latency becomes a concern, right, then you have no other option but to port your Python solution into Java solution. Now, there are also options available, ways available. How many of you are aware of JNI? First of all, how many of you have coded in Java? C++? Okay. Both? Simultaneously? Okay. So if I have to invoke a C++ code or a C code from Java code, how do I do that? There's something called Java native interface. This is a bridge. So there'll be Java runs on JVMs, as you would know, right? So JVM would invoke the C++ library. It will be aware of the C++ libraries, all those things. My whole point is the Python libraries that you work with, I'll connect the dots. They have a C engine. More often than not, you will find they have a C engine under the hood. Okay. So if you work with, have you heard of XGBoost? How many of you have heard of XGBoost? Light GBM? Okay. These are GBDT model libraries. GBDTs, how many of you have heard? Boosted decision trees. These are called gradient boosted decision trees. Okay. You've heard of decision trees, right? Okay, cool. So GBDT is a variant of it. I mean, boosting is a variant of it. Boosting is a technique. I'll go in there. So I'll try to explain those things also. So boosting is a method basically which is an ensemble of trees. I mean, in GBDTs. Okay, forget about the G part of it, but boosted decision trees. Or in boosting, what you do is you first have one classifier. It's a collection of classifiers, ensemble of classifiers. You make your predictions on first classifier. Okay. You find that this classifier has made mistakes somewhere. The instances where it made mistakes, you oversample them in the next phase. So it's a phased one. So now you build another classifier. Okay. In this case, you will overweigh these points, okay, and you will build another classifier. The final classifier will be a combination of these two. You don't have to stop at 2. You can keep on doing. So the number of classifiers in your boosted decision or in your boosting model could be many number of classifiers, and it will be weighted combination of these two. Okay, of these classifiers. If your classifier is a decision tree or a decision stump, stump is a shallow decision tree with only one level. Okay. Then it becomes a boosted decision tree. Okay. The gradient boosted decision tree is that you leverage gradients over there. It's as simple as that, and you can go and read about it. XGBoost is a library which implements GBDTs. Basically, it has GBDT and many other features. Okay. Coming back now, connecting the dots. The underlying engine that GBDT uses or this XGBoost library uses is C++ and C. Same is true for light GPU. Okay. Now, they also give you Python interface. They also give you Java interface through JNI. So now I can develop my models in Python in XGBoost, but since the underlying platform was C++, and the library is giving me JNI capability, it will give me a Java library also out of it, Java classes out of it also. Now I can integrate my model in Java. So all those things, the manual porting that I was doing in the past, right, with logistic regression, the weights, enums, and all things, it has been taken care of by the system. At the same time, I have got the benefits of using multi-threading now with Java. So these are the things that, so what happens now, you don't have to make a network call. You can do in-process inferencing. And even if you host it on a different server, sometimes you want to, so that you isolate your model from your invoker, from your calling systems. Even if you do, on the serving side, on the model serving side, which is in Java, because of multi-threading support of Java, the concurrency and the throughput of that model, of that machine increases. It can scale better. So these are some of the considerations that you have to be aware of when you are deploying your models. It helps. This is a real example. I'm not sure if, how many of you can read it, but on the left is a Python hosted service, right, a web service. And it was giving us a latency of NFR, like I said, was the known functional requirements. At a particular concurrency, the random forest on sklearn was giving me 34 milliseconds. And this was a model which I had to deploy in production. This was a model which was used for RTOs, return to origin problem. Okay. If I'm showing a product, what is the probability that the user can return this product on Flipkart? So if you see, the latency is 34 milliseconds, and as per my contract, so I gave one example of search. Search is one component, but after you search, you will click on that product, and there's another system which is coming in, right? Then you will add to the cart. Another system will come in. Then you will purchase that. After from the cart, you will actually make the purchase. You will payment processing system will come into place. Order placement will happen, right? There will be some validations and checks there. That is this order fraudulent users. There are resellers on the system who are buying quantities in bulk, right, at different addresses and so on and so forth. But these are actually sellers, and then they will buy a discount and they can sell it back to the customers in offline world. Okay. So we have to figure out. So my whole point is that there are multiple points where models will be invoked, right? And one of the things would be that what is the probability that this model could be returned back to us? If it's a very high probability, then most likely that user is actually a mischievous user, or a customer is a mischievous user. And we have seen that orders coming back to us, right? So that is the business problem, the RTO problem. And given that the entire, we have to run so many systems in place, right? Sometimes we have a budget of time that you can serve the output from your model only in so many milliseconds. 34 milliseconds, it's a blink of an eye, but it's too much for a system at scale when you're serving millions of requests. So it was a no-go. Remember, we talked about feasibility and everything, right? So from feasibility point of view, this model is a no-go. Now I'm modeling changed. In this particular case, the solution did not change, right? My deployment strategy changed. I am no longer going to host it on a Python service, but I will try to come up with a JVM, the Java equivalent of it. I will host it on the same machine. I will do it in process. There are many things which are into play, the featureization, the feature vector creation. That also takes a lot of time because of GIL, Python is slow. And we found that if we could do that, we could meet the latency requirements. So this is a real example. MLOps, this is about monitoring the model, as simple as that. Okay. You agree and you figure out what is the standard operating procedure, how are you going to monitor the models, the metrics, and the corresponding remedies. I'm not going into this role of engineering, but PSCs stand for production support engineers. There are production support engineers who keep on monitoring the production traffic if something is going wrong. They are the first line of defense. They will first investigate, but don't worry about that. So you have to, we talked about these cookies and listing IDs. So when you have deployed a model, right, there are a few things. Like I said, it's like an organism, it's like a baby that you have to take care of it. What's the health of it, right? How are the vital statistics compared to yesterday, right? These are the things that we have to worry about. We have to monitor. So one of those things is basically features. Right? Let's say I'm using one feature that my model is saying. Remember, we are saying that we will use 10 days of training data and then rolling period of 10 days. That's one modeling design. So yesterday, what was the distribution of, let's say, number of impressions of different records? It will follow a distribution, right? If I'm using historical impression or clicks of a product, right? At an aggregate level, in my training data set, what is the distribution of clicks, number of clicks that I'm seeing, historical clicks? Now it should not change day over day. So how can I figure it out that that the data that I had yesterday is same as today? Because this is one of the, in many machine learning algorithms, this is one of the core assumptions. The distribution at the training time and prediction time remains same. So how can you figure it out? So maybe you can capture the mean of the clicks. What were the mean number of clicks in your training data set yesterday, right? And you can compare it. Or you could figure out the median, the min max, because like I said, the data sometimes is skewed. So more than mean, you might rely on median, right? You can compare what was the minimum value yesterday, what is the minimum value today, what was the maximum value yesterday, what is maximum value today, right? How many such points can you measure? I mean, these are different points which are telling you how is distribution changing. So one of those ways is QQ plots. How many of you are aware of QQ plots? How many of you know quantiles? Percentile, everyone knows, right? You entered through percentile system. So you divide your data into percentiles, right, percentiles, and I mean these percentiles are called quantiles. Percentile being 1%. I mean each is a percentage point. You divide into 100 points. Deciles will be 10 points. Quintiles will be 5, and so on and so forth. So you divide your data into quantiles. So for the sake of argument, let's say we divide our data into percentiles. So I'll compare my percentiles as of yesterday versus today. Okay? And if they are linearly correlated like this, then your data is not, your distribution is not changing. So this is one way of monitoring it. You could also do probability distribution yesterday versus this, and then you can figure out the distance between the two probability distributions, and so forth. Okay? Sorry? No, it's a very case-specific answer question. I mean, but here the point was the training data distribution we are talking about. What you trained on yesterday versus what you're predicting on today or what you're training on today Is there a distributional shift? And if there is, maybe it is the right shift. So there is no good bad kind of an answer. For your model, there is a good bad answer in the sense that what you trained on and what you're predicting on. Today you predicted on a certain distribution, right? Remember that example that I gave, cookie ID churn, was it churn, right? So the number of cookies, the new cookies today on the 15th day, all of a sudden they are 100%. So from business point of view, they're saying it's okay. From my model point of view, it's not okay. And I have to address it. Okay? How do I address it is a different question. But you have to be, first of all, you first have to understand that there is this churn happening. Right? So you just have to be aware of it. So there's no good bad answer. We talked about, I gave an example of my traffic is changing. I'm moving into different city tiers of country, right? So it will change. May not be, the change won't be drastic over a day, but there could be changes. But when there is a sale going on, the distribution yesterday versus today, right, it will be entirely different. And in that case, we have found to our surprise the model which was working on business as usual days, right, which we call BAUs, right? That model is no longer as performant on sale days because it's getting a different feature vectors now, right? The reason for clickability is different now. There are offers which were not present yesterday, right? There are deals. There is a time sensitive nature of it. The deals are lasting so long, right? So that changes. Now, from modeling point of view, now you have to adopt and adapt, right? From business, it's business as usual. I mean, it changes. It has to change. That's normal thing. Now you go and figure basically how do you address it. This time, yeah. So there are ways. So we'll talk about in case studies. There is online learning. You learn in near real time. Okay. As you see an input, and feedback from the user, clicks, no clicks, you feed it to your model in the near real time and update your model. That way, or you can give more weight to your recent data, something like that. So you can tackle it. But this thing here, we are talking about monitoring and keeping a tab, having a control on the data. Do we understand our data or not? That is critical. And this is the staleness that I was talking about. You look at this data, right? I trained my model on 21st and I'm predicting on 22nd. This is the raw KUC of that model on the model which was trained till 21st. If I used, let's say, 3 weeks of data, so it was trained on 1 to 21 days. If it was 2, 15 to 21. So you see, this is fluctuating. In fact, it is going down steadily here. There'll be few variations also. There's a possibility that on 25th it could be lower than what it is on 26th. So those variations are fine. We talked about it. Sample variance. There is a sample variance can cause a model variance also within a tolerable range. Right? But you see this, there's a staleness here. Now, what is the cost of retraining your model is another factor that you have to be aware of. If the cost of retraining your model is heavy, let's say you can't retrain on a daily basis, then, but if someone tells you that no, you can train on because sometimes trainings take a lot of time. They can run into days, they can run into 10 hours or so if the data is huge. Okay? So maybe it's not possible for you to retrain your model on a daily basis. But if you're seeing this drop, then you can figure out what is the right spot, what is the right training frequency for your models. Or you change even the reason that I gave was maybe data, but if data management is an issue, then you change your training strategy. You shift to online learning. But the whole point here is that you first of all need to have a grasp, a handle on your model's performance. How is it changing with time? I just trained it on 21st, and then I'm not training it until 26th. I'm just doing prediction, and there is a staleness. Sorry, there's a drop because of the staleness. And this is gradual, right? So you have to be careful about how you are measuring this shift. Okay. Because if I compare 26th with respect to 25th, there is not enough change, right? Or it is within tolerable limit. I'm comparing 23rd with 22nd, there is not enough change. But if I'm comparing 22nd with 26th, right, there is 1.5 absolute percentage point. So we talked about these The training and serving parity. How do you do it? We also took an example, right? You take a sample of request, which on which the model was used, or on which the model predicted in production in the real traffic. You log the score, you log the feature vector. Ideally, you should log for all of them, but sometimes if it is beyond scale, you log for sample, but you do log them. Okay. Then you take that sample back home in the sense to your development box, and you invoke your model again on that raw data. You featureize it, you invoke your model again, you run the entire offline pipe, the evaluation pipeline that you had, right? You do that, and then you figure out the disparity in the scores, in the features, right? Okay, metrics, we'll talk about this position bias, but sometimes there is a disparity which is possible. We'll talk about it later, okay? So I'll skip it for now. You also have to be aware of feature leaks. How many of you during this session or before have you heard about the term called feature leak? Okay. We casually touched upon when the question was asked that why we use snapshot versus historical, right? How many of you have participated in Kaggle? On Kaggle, at least in my experience, I've seen some of my data scientists who have participated in Kaggle. There is a featureization process which they use. This is called target encoding. You are given 10 days of data, training data, model training data, okay? And you have to learn from it. So let's say CTR, I have to again predict the CTR. It's a beaten to dust example, but it's a practical, and you will find a couple of challenges on Kaggle also. Criteo is one and Avazu is another. So there, if I want to use some feature, let's say for an ad ID, the feature that I want to use is not the ad ID per se, but what was the CTR of that ID, historical CTR. Okay. I want to use that as a feature. Ideally, I should use past as an indicator of future, right? But here it is 10 days of data. Sometimes people, what they do is, they'll look at the CTR of an ad in those 10 days. Okay. Now they already know on day one how this ad is going to behave in the training data. Okay. While on the day one, my feature should have been its past performance. I did not use it, but I rather used the performance of that ad in those 10 days. So I've peeked into future, right? On the 10th day, how it will perform. And these problems become more magnified, more pronounced when you have sparse clicks, and such data points are huge, right? Where you have 1 or 2 clicks. Now for those guys, you will be predicting 100% accuracy because you will, right? However, for the guys actually for whom you have enough impressions, even in those 10 days of data, their CTR that you will see will not be very different from the historical CTR. So that is okay. But for these guys with sparse data counts, right? There are ways to alleviate it, but my whole point is that there is this feature leakage that you have done. And it's a live example. We have done it in when we were experimenting. One of my data scientists did that in Flipkart. We were working on recommender systems. So we were doing ranking. We used historical impressions. Okay. Somewhere there was a problem in the bug was in the engineering pipeline also. Though the data the pipeline was giving was till yesterday, but accidentally that it was also leaking in today's data also. Okay. So because of that, while we were using historical counts, my count was till today, and I was training on today's data. And I was pleasantly surprised when, oh, this is a wonderful model. I got an absolute 7% improvement in AUC, which is very, very rare. Okay. And we were very happy with it. We'll take it to production. We took it to production and we had a hard fall. Okay. That model bombed. The metrics were negative. The purchase rates had come down, and we were aghast what has gone wrong over there. But it was a classic. When we debugged, it took us around 1 month to figure out, oh, there was a case of feature leakage. So even with experienced data scientists, these problems can happen. So you have to be aware of that. Especially when you see such vast improvements, pinch yourself. Maybe too good to be true. These are very simple things. This you do anyways. Create dashboards, right? You see these dashboards anyways for stock prices. You do the same thing for your model. You create dashboards for your model metrics. How are they trending over day? If possible, hour by hour. That's okay. Okay. But also look at the business metrics. Your model metrics might be doing fine, right? Sometimes we had seen that when I trained a model on regular days and I served that model in my sale days, right? User behaviors had changed. My model's raw KUC also remained same, but my CTRs changed drastically. Okay. And that can happen. So when you're looking at so you should not look only at your model metrics, how it is changing. You should also look at business metrics. And sometimes that's why no single metric is sufficient. You need to come up with multiple metrics. Maybe in that particular case, had I monitored my MRRs, the position at which I was getting clicked they might have gone down. And I'll when we go to real case studies, I'll talk about why position plays such a big role. If I show the same content on first position, you will have a bias because of the position. You will think that is more relevant. But had I shown it on the 10th position, your click-through rate, your purchasability, overall purchasability will be lower on that. Okay. What I'm trying to say here is that you need to have more than one metric. If I was simply using one metric and hoping that it translated into business metric, it may not be the case. But you need to monitor. Here, the point here is that you need to create dashboards. You monitor them. Okay. And when there is a delta, when there is a change in the metrics, you create alerts. You would get emails, right? And then you spring into action. The first line of defense, like I said, would be production support engineers and other systems, but you will be involved at some point in time. You also should have a rollback mechanism. Maybe there was a rogue model actually which made its way through production, right? Can you roll back to previous version? That's why we talked about versioning. Did I maintain the previous version of the model? But if I did not, then I'm doomed. Right? SQL database, if I'm using my SQL database for features, can I go back to even the data version? Can I go back to previous version of the data? Yeah. These are a few things you would want to automate your model trainings so that the chances of errors are reduced, right? More automated, better it will be, but automation has to be done with some quality guardrails and quality checks. When you're doing your model training, it could also optionally include a hyperparameter tuning at the same time. Remember, I gave that example where the model was degrading day over day. So then I have to retrain every day. If I have to retrain every day, maybe there's a distributional change. Maybe my hyperparameter would also require some training, right? So maybe I need to do the entire training again. So just automate the model training, it will help. And then automate the deployment also. If I have manual steps, it will be prone to error. But auto deployment, you need to be also worried about how do you deploy it. There is hot deployment. Traffic is coming, one model is serving. Can I serve on the same process, on the same server? Can I have another model? That is called, and when the next traffic comes, it will switch to the next new model. That is called hot deployment. I don't have to bring down my servers, and that is critical. So it reduces the downtime of your system and infra. The other way to do that is that you deploy first on machine number 2. Machine number 1 is serving. When deployment on machine number 2 is done, you switch your traffic to machine number 2. That is active passive. Next time when you have another version of the model, the machine 1 which became passive, you deploy onto that and switch back. So this is called active passive deployment, right? And all of these things can be automated. How many of you are aware of cron schedulers or cron tabs on the Linux systems? Shell script, how many of you have written shell scripts? Okay. Shell script is also code on the command line, right? You could automate them. You could write all these commands. So first line could be train model. Second could be check metrics, the code for that. Third line in that command, it's a batch file kind of a thing. Third line could be deployment to the production. Fourth line won't be there. Okay. Sorry. Ansible, I'm not aware. but it's a scheduler nonetheless. You have a sequence of steps. Okay, some of them actually could be DAGs, directed acyclic graphs, because when you're generating data, sometimes you could generate your data in parallel, so you don't have to generate data one after data two. Right? So let's say if you have to get your feature vectors from different sources, user data from source 1, click data from source 2, impression data from source 3. So you can generate them, write the pipelines, write the commands or SQL queries separately. So this could be DAGs. These are some of the tools: MLflow, Airflow, Metaflow. Metaflow is by Netflix. These are schedulers, as simple as that. Just like your OS has schedulers when there are multiple jobs running, right? You schedule, you figure out the sequence and everything. These are schedulers. But the whole point is automation. Cool, that's it for session 1. This was, I know, pretty dry, but I thought I peppered with some examples that might have made it interesting. I have another things. Okay, can we get this presentation? Yes, I will share it later. Yes. You're right. It's tough. It's tough. First of all, there are layers. I mean, like you said, if layer 1 is doing some prediction and then the output of it or the response data set of it is going to layer 2, right? It's possible that something has changed in layer 1 and model 2 is not at fault. So these are few tough things. You built your checks and balances at every step. But when you have at least layered things, it's tougher. But if it was spell correction, right? If spell correction versus query ranking, product ranking, then, and if I made a change in spell correction, right? Maybe I have made good changes, but that distribution was never available to the ranker. Then sometimes what we do in offline is that we create combo experiments. Okay? So when you're experimenting with spell corrector, you will also retrain on the data. I mean, it requires a lot of efforts because now you will have to simulate and other things. And a lot of problems in real world comes from counterfactuals. What if I had shown this, then what would have been the response of the system? But if I leave that aside, if I could retrain my ranker now with a new output, so that would be another AB. So these are Microsoft, we used to call them combo ABs. So even though the system 2 is not what I'm touching, but it requires a retraining of that model because of this distribution change. So that is something that. But otherwise, it's a tricky problem. Right? So how do we go about it? Shall we go into the session 2 or do we take a break? Sure. Yeah, we're at almost 1:45. Yeah. Sure. That's a logical break as well. But if there are any questions you want to ask, happy to take. Or if you are feeling shy that few things are way not relatable, then we'll be having lunch and we can have questions one-on-one. And remember, there are no stupid questions, right? These are basic questions. The questions will be basic. No, nothing will be stupid. So don't worry about it.